Today's experiment will be discussing about the determination of critical micellar concentration of a surfactant. Critical micellar concentration is also known as CMC of a surfactant. CMC is determined by drop count method, and in this experiment we will be making use of an instrument known as stalagmometer. Now let's get into the experiment. Our aim is to determine the micellar concentration of the given surfactant by a method known as drop count method. Now, to determine the micellar concentration of a surfactant, the most important instrument that we need is the stalagmometer and the surfactant we need. We'll be considering any two surfactants for comparison. Let's consider sodium lauryl sulfate or 280. Let's see the theory involved in this experiment. Why is it necessary to determine CMC of a surfactant? Critical micellar concentration, the name itself indicates the concentration of a surfactant matters. CMC has a definition which includes a concentration range at which the micelles are formed. Now when we see at this figure, these are the surfactant molecules at certain concentration. When we keep on adding surfactant molecules, they'll form micelles. The principle of adding surfactant molecule to a solution is to decrease the surface tension and to improve the solubility of particles in a system. So when we add a surfactant molecule, it tries to decrease the surface tension between the two phases or at the interface. When we keep on adding surfactants, when we keep on increasing the concentration of surfactants in the formulation, it results in the formation of floccules or a group of surfactant molecules, and this is known as a micelle. It is at this point where the solubility of a particle in a system increases, and it is at this point the surface tension between the two phases decreases. So all the particles, the individual entities of surfactant molecules will tend to come closer and form a micelle. And if the phase in which the micelle forms is hydrophilic in nature, this hydrophilic head of the surfactant tends to get closer with the aqueous surface. Now, as the concentration of surfactant increases, the surfactant molecules in the system and at the interface also increases, and at certain point it becomes saturated. The bulk phase and the interface, the bulk phase and the interface will get saturated and they tend to form a micelle. The concentration of surfactants at which the micelle is formed is known as critical micellar concentration, and it is at this concentration the surface tension between the two phases will be reduced much. And beyond this concentration, though we add surfactant molecules, there will be no further decrease in the surface tension. These aggregates are known as micelles, and it is very important for a pharmacist to know at which concentration of a surfactant it forms micelles. Beyond that, beyond that concentration, even if we add surfactant, there will be no much decrease in the surface tension. So this is actually the importance of conducting this experiment, to know the CMC of a given surfactant, so that we'll come to know, or we'll get to know the amount of surfactant to be used in a formulation. This is a theory involved in this experiment, and let's see what is the principle. Principle: if a surfactant is added in lower concentration, the surface tension between the two phases or at the interface decreases. If we still keep on increasing the concentration, the surface tension will gradually decreases. But if we keep on still increasing the concentration of the surfactant, the system gets saturated with the surfactant molecules, and after some time, even if we add surfactant molecules or surfactant solution, there will be no much change in the surface tension. There will be no decrease in the surface tension. It gets saturated. So at that point, where the surface tension remains constant, shows micelle formation. Means at the critical micellar concentration, the surface tension remains constant. Now, by taking this into consideration, we will be performing an experiment by a use of an instrument called stalagmometer. This is the stalagmometer. It looks like a graduated pipette with two markings, the upper marking and the lower marking. This is how the stalagmometer looks like, and it has a bulb at the center, and when we look at the construction of stalagmometer, we have a bulged portion at the center. This is called bulb. Above the bulb we have upper marking, and below the bulb we have a lower marking, and this is called bore, a narrow opening. The other end is an opening which is connected to a rubber tubing. This is the construction of a stalagmometer. Now, let's see how can we work on this instrument. This stalagmometer is attached to a rubber tubing and is set up to a stand. In this container, we'll be taking our surfactant solution, of which we need to determine CMC. We'll be pipetting in the solution through this tube till the liquid reaches the upper mark. Now, carefully close this, take out this container, place another container and release the pressure here, release here the closed finger, and slowly the surfactant solution falls from this mark, the upper mark. So make sure that to note down the number of drops formed when the liquid falls from the upper mark till the lower mark, this one. It is really very important to note down the number of drops formed when the liquid is traveling from the upper mark to the lower mark. Count the number of drops formed. As this procedure is based upon the drop count method, we'll be counting the number of drops formed. If we are following drop weight method, then we'll be considering the weight of the drops formed. Now let's discuss about the drop count method. The number of drops formed for this liquid is measured and it is noted down. Take out the sample, wash the stalopometer properly, dry it properly, and again take another sample, another surfactant sample of different concentration. So this is actually used to determine the surface tension of a given surfactant solution. This is how we will be determining uh, the surface tension. But in today's experiment, we are considering the determination of critical micellar concentration. Hence, we need to take a surfactant solution in varying concentrations. We need to check at which concentration the surface tension becomes constant. So for the first sample, we'll be taking, say, without addition of surfactant, we'll be just taking water as a sample and we'll be checking for the surface tension. First step, take water as a sample and run the experiment and calculate surface tension. And again, take sample solution of specific concentration and run the experiment. Note down the number of drops formed. Similarly, for the third another sample having a different concentration, likewise, we will be determining the number of drops formed for different concentrations of the surfactant solution. Let's see. How can we calculate from the number of drops formed? Now let's see. The first one will be a plain water solution. We'll be making use of no surfactants and calculate the number of drops for trial 1 and trial 2. Take average number of drops. We know the density of water. Note down the density of water. And then by means of a formula, we'll be able to determine the surface tension of water. Surface tension of water is given by a formula and it is constant. Surface tension of water is constant. It is 71.5 dynes per centimeter. Now incorporate this value in this table. Now let's take the second sample, the solution containing 0.5% of surfactant solution. Similarly, run the same experiment, run the experiment with the same procedure. Note down the number of drops formed, trial 1, trial 2, and take down the number of drops formed. And the density of the surfactant solution by means of specific gravity bottle, we'll get to know the density of the surfactant solution. And density remains same. And calculate the surface tension. Now we have increased the concentration 0.1. Note down the number of drops and the same story continues. Average number of drops. Density remains same. The number of drops formed will be changed because we have increased the concentration. And so is the surface tension. So likewise, the number of drops formed for each concentration is determined, and surface tension for all these concentrations are calculated. After we get all the calculations, we need to plot a graph by taking surfactant concentration on x-axis and surface tension on y-axis. So as the surfactant concentration increases, the surface tension is supposed to decrease. So at the beginning it will be higher, slowly it will be decreased, right? So but after some time, after some concentration, even if the concentration increases, there'll be not much change in the surface tension. It might remain constant or it might increase. So at this point where there is no much decrease is seen, and at this point is known as CMC, critical micellar concentration, the concentration of surfactant at which there is no much decrease in the surface tension is seen. It either remains constant or sometimes it might increase. So that is how from the graph we can determine critical micellar concentration. And this is how the calculations are made by making use of a formula gamma 2 by gamma is equals to rho 2 n1 by rho 1 n2. Surface tension of the surfactant of particular concentration, which we have got already in observation table, and gamma 1 remains constant, and densities remain constant. So it is only the number of drops formed keeps on changing with different concentrations of surfactants. That is how, by means of drop count method, we'll be able to determine the critical micellar concentration. And from the graph, we'll be able to conclude the critical micellar concentration of a given surfactant. And thus the CMC of the given surfactant was found to be how much percentage. From the graph you can easily mark and you can report it. This is how we'll be carrying out experiment to determine critical micellar concentration of the given surfactant by means of stalagmometer, and the principle used in this experiment is by drop count method. If you have any doubts, you can ask me through mail. This is the end of the experiment.